And for the next step, I would like you to understand and some of the instinctive understanding of light absorption. So as I mentioned several times, light is called the electromagnetic wave because it has oscillation of electric field and also a magnetic field perpendicular to this electric field. And this electric field can induce the oscillation of the charge and dipole in the molecules, meaning the electron cloud is modified or modified by the light of electric field of light. So you can imagine that, for example, if the molecular kind of crowd and irradiate the oscillation, probably this could oscillate the dipole because this plus minus could be induce somehow some modification to this dipole. But for example, if you think like this, so in this particle direction, there's no dipole. So meaning that this light, even if it's oscillate vertical direction, it would not induce modification to the electron cloud. So we have to understand how to change this electron cloud distribution, which is given by the transition rule defined by the group theory. In the group theory, molecules or even light can be categorized depending on the symmetry of the geometry. So depending on the geometry, so for example here, the particle in the vertical direction, that's symmetrical, but in the vertical direction of this molecule is somehow unsymmetrical. So this kind of symmetry can be categorized depending on the molecules, and even the molecular orbitals could be categorized into the, and then based on this group theory, you could calculate if the light absorption, meaning the interaction between the electric fields of light and the molecular cloud, could be possible or not. That's the transition rule. So in the transition rule, in theory, could be explained by the quantum mechanical theory, which is the Hamiltonian for the ground state of molecules. And suddenly, by radiation of light, this Hamiltonian is changed by addition of extra Hamiltonian, which indicates the interaction between the molecules and light irradiation. So we are not going into detail about the mathematical procedure, but simply I would mention that H0 is the original Hamiltonian of the molecules, so which gives the energy of molecules. And this Hamiltonian includes the interaction between the original molecule, nuclear electron and electron-electron interaction. However, the additional Hamiltonian is given by the light, and meaning the most likely electron and electromagnetic interaction, what I explained in the instinctive understanding of the interaction between molecules and the electromagnetic field. And don't take it very difficult, but it's simply could be understood like this. And by addition of the additional Hamiltonian, you could modify the wave function, meaning the simply the distribution of electron cloud, and the energy could be calculated. Okay. So, for example, in the perturbation theory by additional Hamiltonian, for example, you have two different molecular orbitals, phi1 and phi2, and in the ground state, the original wave function, initial wave function, is simply this 1 times phi1 plus 0 times phi2. But by addition of the h prime, finally your psi of the wave function is changed to the C1 phi1 plus C2 phi2. So it's making the mixture of the phi1 and phi2. Right. So this is an excited state for light absorption interaction. And what you have to obtain is just simply this coefficient, how much mixed for the first and the second molecular orbitals. And by this simple explanation, and then I'm going to talk about some of the key issues and the probability of the, for example, probability of electron staying in the orbital phi2 is proportional to the C2 squared, right? And what we are interested in is by irradiation of light, the initial state to final state, so ground state to excited state probability is given by this equation is S equal Q psi I H prime psi F D. It seems arbitrary and not so much clear, but you can think like, you know, that these are wave function, which is indication of the electron cloud. So this is initial electron cloud and final type of electron cloud and some Hamiltonian, at this moment unknown. They are multiplied and take the spatial integration, which is calculated by the computer, and you could obtain the S value, which is the probability of the transition. And this is a transition rule. And if the S is not 0, this transition is allowed transition. And if S equals 0, this is forbidden transition. So just by calculating this S value, transition integral, you can obtain the transition probability. So now you could calculate that how much this transition is possible or not. So, however, one of the important point of this wave function and S value is here. The wave function is actually not only by this electron cloud configuration, but actually it includes several different terms, which are phi, chi, S, and I. And phi term, which is electronic transition, which is most directly related to the electron cloud and obtained by the interacting with the UV and visible light radiation. But there are other components. One of them is chi, indicating the nuclear motion, indicates the atom position is changed by the vibration and rotation, which is typically observed in the infrared absorption. And the other is S, which is electron spin. Electron spin can be observed if you want to observe it, you could observe in the microwave absorption. And also I, nuclear spin, it's observed by radio wave. So this wave function actually includes several different terms. And since this one is an integral calculation, even though the light absorption itself interact with phi, but the other values also affect the final value of the S. So if we write down these terms explicitly, so it could be the phi E I initial and H prime Y E F the tau. What the other term chi and I chi and F the tau and SI SF the tau and IF the tau. So many different terms you have to think about for the final output of the transition probability.